Welcome. All right, so this is a little help video if you need a little help with the circles homework. All right, so the first question here, you're naming the following segments in the circles shown. Use correct notation for a segment or line. As a reminder, segment has the line over it. So if I wanted to say segment, I'll choose something that's not in here. PQ, there's no PQ. That would be, I'd write the two letters, the two endpoints, and put a line over it. And that would be PQ. Or if I wanted to do one that was shown in here, so let's say I'll take segment JK, right? So that goes from there to there. I'll just move the whole picture. All right, so it starts at J or K and ends at the other one. All right, so the endpoints are JK. I would put the line above it. If I wanted the line JK, right, that has an arrow over it. Right? So the line keeps on going, and it shows that by using the arrow symbol. Okay, so there we have, try not to overlap them. Maybe if I bring the red out in front, just trying to show you how, it doesn't want to come up in front, how to, what happened to my arrow? There it is. How to distinguish between, bring to front, a line and a segment. Did that move in front? No, probably hit the wrong one. Oh, that's okay, I think you can see it. All right, so just as a reminder, the different segments, radius goes from center to edge. Chord, both endpoints are on the circle. Diameter is a type of chord, but diameter is a chord that goes through the center of the circle. Or intersects the center of the circle. So it has two endpoints on the circle, and then it intersects the center of the circle. A secant is a line that intersects the circle in two places. I seem to have forgotten to write half the words I just said. And a tangent is a line that intersects the circle in one place. Right? And just get them right over here. The tangent is perpendicular, that took a little while, to the radius. Right? They meet at right angles. Let's see if I can move that out a little bit. That's a T, meet at right angles. There we go. All right, and so you're just going to name these and use the right symbol. Is it a segment? Does it stop, have endpoints, or does it keep on going? Is it a line? Right? Right? In circle C, AC and BD are diameter. So always make sure you read the directions because that helps you out. So this is a diameter, and this is a diameter. Remember that a diameter divides a circle in half. A circle has 360 degrees. So if I divide it in half, half a circle, or a semicircle, let's write semicircle and call it half a circle, has 180 degrees, right? So that gives you a big hint, right? So that means that that's 180 degrees. And of course, on the other side would be 180 degrees, because BD is a diameter. This is also 180 degrees, because AC is a diameter. Well, now that you know that that is 180 degrees, you know how to find x, right? Because all of these labels here, 6x plus 5, that's this central angle. 5x plus 3 is this central angle. And 8x plus 1 is that central angle. Right? And we know the central angle equals the arc. Right? So if the arc is 180 degrees, the angles add up to 180 degrees. So to find x, add the angles, and they're all labeled there with those x's, and set equal to 180 degrees. And you can solve for x. Once you know what x is, you can find all of the angles here. To find the angles, just substitute x into the expression to find angles. And that would help you with, let's see, we got A, Q, E. Yep, that's one of the expressions. We have C, Q, D. That's one. The AQE is the 6x plus, I don't know, what does that say, 5. I put a line over it, so I can't read it anymore. 5. So once you know what x is, just substitute x in that expression, and you have that angle measure. CQD is 8x plus 1, so just once you find x, you can find that one. CQE, you got to add two of them together. You got to add the 5x plus 3, and actually I won't tell you what to write in there, but I will tell you that CQE is EQO. That's what happens when you write over the letters. EQD is EQD plus angle, so let's see, CQE is all of, gotta stop writing. Yeah, let's get rid of this for now. I will leave that. But CQE is that angle there. So you can see it's angle EQD plus DQC, or CQD. It's the same thing. Right? Angle DQE is right there. That's the 5x plus 3. BQC, right? So, well, together, angle CQD plus angle BQC equals 180 degrees, right? That's I don't know what color to write in anymore. That's this right there, right? So that's 180 degrees because BD is a diameter. So together, the two angles equal 180. If you subtract out CQD, which you found in number 3, you got angle BQC. And then angle AQD, that's just, I don't write red now, or purple now, angle AQE plus angle EQD. Right? Because that would be the one that's in red, not covered over in purple, right? That would be this one right here. Oops, now it's purple. I forgot I had purple out. Here, I'll make it red. All right, so there's big, big hints on this one. Right? There you go, there's that angle. All right, so once you got X, you just plug it in, and you might have to add more than one angle together. All right, so here FH and EG are diameters of circle P. Find each measure. Here you're not solving. You're just having to add some numbers together. Right? Realize some angles might be congruent to one another. These are diameters right here. So you always want to read the directions. Because once you know these are diameters, you know, for instance, that would be 180 degrees, and that would be 180 degrees. Right? You've got some vertical angles in there. You already know one angle is 90 degrees. You got several vertical angles, right? Because you've got intersecting lines. And remember, vertical angles, because the diameters intersect, formed by intersecting lines, are congruent. So this is not too hard to find. And remember, the central angle equals the arc, right? So the arc is the same as whatever the central angle is, right? So if the angle's 90 degrees, the arc's 90 degrees, right? So if you need more help than that, email me, or we can set up a Zoom session, and I can help you look at your work, right? But I'm going to go on to the next one. Find the value of the variables in the problem below, right? Make sure you set up an equation, right? So little reminder, this applies to 13 and 14, that when you have a central angle, or excuse me, you have an angle in the circle that's not at the center, just an angle inside the circle, it equals half the intercepted arcs. Making guess I can't move it apart. I'm taking up too much space. I'll put it over here. And those intercepted arcs are across from it. And I should say, when I say half the intercepted arcs, half the sum of the intercepted arcs, just to make that clear. So those intercepted arcs are the ones that I'm pointing to with the arrows, right? These are the intercepted arcs. They're the ones across from the angle, right? So if you add those together, divide by 2, you have your angle to show your work. For the next one, look carefully at our angles and notice they have something in common. Look where their endpoints are. Their endpoints are in the exact same location. So angles that, and I should say inscribed angles in particular, inscribed angles, so those are the only ones that could share an arc. Inscribed angles that share an arc are congruent. So there's a hint. And inscribed angles are half the arc, half the intercepted arc. And finally, the last one on this page, we have a quadrilateral inscribed in a circle, right? And there's something special when we have a quadrilateral inscribed in a circle. The opposite angles are supplementary. Right, and this is for a quad inscribed in a circle. Nowhere to write. Right? So the ones that are opposite or across from one another, And supplementary, as a reminder, means adds to 180 degrees. All right, so I hope that helps you on these problems. Let's take a look at the next set of problems. All right, so here we have a tangent. Tangents that intersect in a point are congruent, so you can just set those equal to one another. All right, now here we have a right angle. And by the way, that applies to both of these. We have two more tangents that intersect in a point. How we know they're tangents? They meet the radius at a right angle. How you know 17 is a tangent? I did say anything that looks like a tangent was a tangent. And here you have a right, oh, such a beautiful right triangle. But you have a right triangle there. So in addition, you can use Pythagorean theorem to find B. Yeah. And not only are tangents that intersect in a point congruent, all radii of a circle are congruent. Here we have another inscribed angle, and the inscribed angle equals half the intercepted arc. If we go the other direction, in other words, we're looking for the arc, the intercepted arc equals 2 times the angle. Okay. So if you double the angle, you have the intercepted arc. Right? And these ones are very much the same, but be careful what you're looking for. This one is easy. This one, again, is the angle equals half the intercepted arc. By the way, you should be writing these formulas so that you remember it. Here, you're looking for Q. The only thing you don't know is PM there. But together, arc PQ plus arc PM plus arc QM equal the whole circle. They equal 360 degrees. Right? And then once you know what PM is, again, the angle is half the intercepted arc. And the same thing over here. The angle is half the intercepted arc. Notice that this right here is a diameter. I think that should help you be able to figure out how much that is so that you can find JL. And then once you know what JL is, the 26 degrees, by the way, is this angle here. Once you know what JL is, you can subtract and find JK, because together we've got half a circle there, right? And again, intercepted arc is the angle is half the intercepted arc, or you can think of it the other way, the twice the angle equals the arc. And of course, the intercepted arc is the, so this was the diameter. If you follow the angle out, the intercepted arc is the one that's between the angle, right? So that's the arc, and that arc is twice the angle. We have a diameter, and we know a diameter divides a circle in half. I'll even write that in there again. All right, let's look at the next one. All right, so this is similar to one of the other problems where we have the angle equals half the sum of the intercepted arcs. But that's this angle right here that's half the sum of those arcs. Right? But together, let's call that angle 2. Angle 1 plus angle 2 equals 180 degrees. So you can use this to find angle 2. Once you got angle 2, angle 1 and angle 2 together add up to 180 degrees. Right? We're looking for angle 2. Angle 2 equals half the intercepted arc, and the intercepted arc is ST. Notice that together, I wish I could outline that proper. Oh, that's not too bad. Together, the two arcs equal the entire circle. All right. So the arc that you're looking for really needs another letter because it's a bigger. It's a bigger ST. Let's just call it SUT. It's the major arc, not the minor. They really should include another letter in there. So arc SUT, the larger arc there, angle 2 is half that arc, but together the minor arc ST and the major arc, which I just call now SUT, together equal an entire circle. As does this one over here. All right, so I'll just put like a P here. Arc MPK plus arc, the minor arc MK, together equal the whole circle. Right? And then again, the angle equals half the arc. So once you know what arc MK is, you can find the angle. Right? So lots and lots of help here. Right? I'm going to try and go through a little quicker. So here we have, for every one of these, the formula is exactly the same. I'm not going to set it up with telling you which arcs to use, but I will kind of point them out. So in every one of these cases, you have an angle outside the circle. On that last page, they were all inscribed angles, but I'd written inscribed angles so many times, I just put angle. All of these are angle outside the circle, and that's going to be half the large arc. And I call it large arc rather than major arc because it's not always a major arc. The requirement for a major arc is that it's greater than 180 degrees. So large arc, whichever one's larger, minus the small arc. All right, so in all three of these, exact same formula. All right, so and those large and small arcs are created by the angle. They're in between the angle. So there's the two arcs, and I think you can figure out which one's larger. A, it's further away from the angle, and it's the bigger number. All right, here you'll use the exact same formula. Angle outside the circle equals 1/2 large arc minus small arc, but you're solving for the small arc because you already know the angle. And then over here, exact same thing. Here is the small arc. Here is the large arc. You're solving for the angle, but first, you got to find QT. Arc QT first, but a little hint, arc QT plus arc ST plus arc QS add up to the whole circle, 360 degrees. So once you find that, then you can just use the formula, large arc minus small arc. And of course the large arc's the bigger number, and it's further away from the angle. Right, here, same thing, all three of these. Hey, is this the same questions twice? Did I just duplicate? Yes, I did. Okay, so we'll just skip by this one. I should be 7, there we go. 8, 9, 10. Same thing for all three of these. Angle equals 1/2 large arc minus small arc. All right, and there you go, large arc and small arc. Doesn't matter, they connect. And again, this is angle outside the circle. Here's the large, Here's one arc, sort of badly drawn. Right, that's the large one, the further away one. That's the small one, also badly drawn. Right? And you're looking for the small arc. Label that one X. All right, I'm going to help you with the setup here. Label that one X. Together, arc CE. Let me write that nice. I'm going to put the big arc first. So arc CYE plus arc CE equals the whole circle 360 degrees. We've already said that arc CE, because that's the one we're looking for, we're going to label that X. So now you know what to label arc CYE. Arc CYE is 360 minus X. Right? And then you plug it into that formula. Right? The large arc minus small arc divided by 2 is equal to the angle. In this particular example, of course, the CYE is the large arc and the CE is the small arc. It's smaller, it's further away from the angle, it's closer to the angle, right? So CE is the small arc because it's smaller and closer to the angle. Arc CYE is the large arc because it's farther away from the angle. And then last, same setup, except this time you're looking for arc YAB, make this one X. So what do you think arc YB is going to be equal to? Well, just like in the other problem, now YB is going to be 360 minus X. All right? And all of these use this formula here. That, I believe, is the last problem. If I see a blank page, or the same problems again, a blank page. That's the end of the problems. So I hope this helps you out in answering these questions. Bye for now.